should be starting. Oh yes, yes, we are online finally. Okay, so hello everyone. I'm very happy to be here with two great members of TerminusDB. So first of all, I want to let them introduce themselves. Maybe Gavin can start.
Yeah, I can start. I'm Gavin Mendel-Gleason. I'm the Chief Technical Officer at TerminusDB and one of the founders. And I do a lot of the technical design of the underlying transaction processing system.
Cheuk.
Yeah, so I'm Cheuk. I'm the lead of developer relations in TerminusDB. So I kind of oversees like the community of of TerminusDB. We have a lovely community. So if you don't know, join Discord, you will find out. And also I take care of the Python clients. So yeah.
Great. So first of all, I want to say that I'm very happy about this interview. I've met Cheuk and Gavin in London for a meetup we organized at London Open Source Databases Meetup some months ago, last year actually. TerminusDB is a new technology, so and I have to say an interesting one. So I want to start with a classical question that everyone asks in case of a new technology. And the question is, there are a lot of databases out there of very different types. There are also a lot of graph databases. So first of all, why you decided to build a new one, and how Terminus differentiates from other graph databases. Whoever wants to start is okay.
I'll go ahead and start that. So the idea like that we had started in Trinity College Dublin, and we were working on a project called the Seshat Global Historical Database, and that project was to store information about all polities in human history, and we'd have to track information about the populations, carrying capacity, which religions they had, all sorts of different kinds of information. And so it was a very challenging project in terms of just the complexity of the schema that was involved. So trying to model it in a relational database management system was proving very difficult. And so we started looking at graph technologies as a way to deal with the complexity. However, the graphs that we encountered didn't really have a strong modeling component to the graph, really. And we had some experience with the linked data community, and so we knew about OWL as an ontology language, as a way to describe ontologies about very complex and rich data. And so we started looking around for some sort of database technology that would enable us to store information to use with an OWL ontology. Unfortunately, the space of offerings there was actually pretty narrow. So if you want to use a graph, there's some good graph databases out there. There's Neo4j and lots of other ones beside. But in terms of like really having complex ontologies, there wasn't that much out there. So we started evaluating different types of approaches. We evaluated Stardog and a few others, and we eventually just came to the conclusion that we should write our own. So we embarked on actually doing so. Now the design of the database has evolved over time. So that was the initial reasoning. Later on, we began to start adopting the sort of Git for data type approach into the database itself. And so because we are managing, curating large data sets that are very rich and evolve over time, the schema also evolves over time, and it's difficult to have collaboration over that kind of data bank. And so we started folding in features from Git, including branching of databases, rollback, time travel, and all of the things, rebasing, all of the things that you expect from a Git. We have implemented them on a graph database with a strong semantic ontology layer. So that's in a nutshell.
Yeah, very interesting. Chuck, you want to add something?
Well, I think Gavin is the perfect person to answer that question because I think I joined I think I joined last year. So when like TerminusDB was it was taking off but it's already there. It's very nice. So yeah.
Okay, great. My next question is probably expected for you. How did you decide to use Prolog?
So
Gavin, that's your question again.
that's another, yeah, exactly. So initially, we actually wrote, we started writing the prototype in Java. And as I was writing the Java code, I was writing constraint checks in Java. And I just got the feeling like, I'm writing a backtracking system that feels very much like Prolog. And then I'm querying the system in Sparkle, which feels like a very stupid Prolog. And so if you combine those two things, I thought, well, why am I doing this? And I recognize that, like, because the backtracking algorithm I wrote in Java was sort of embedded inside of Java, it was likely to be even slower than a Prolog system. So I thought, well, I'm just gonna evaluate using Prolog directly for this, and so I tried it, and it was faster and it was easier. It caused a lot less problems, and for query, it was much more flexible than Sparkle. And I thought, okay, I'm just gonna try, expanding this approach and using Prolog as the main sort of query and constraint checking system for the database.
I expected the part of the answer about queries, but I'm really, really surprised that you say that it's faster.
Than a poorly written Prolog in Java. So, I mean, if you're doing constraint checks, there's various different techniques, and it depends on how you do the constraint checks. But the sort of naive algorithms are to use some sort of backtracking. When you run into a possibility that doesn't work, you try the other options. And a naive backtracking approach is unlikely to be implemented as well as they tend to be implemented in Prolog. So you have a compiler that's been written using techniques that have been developed over 30 years that is supposed to make unification and backtracking fast. And so they've gotten really good at those sorts of techniques. And so if you just leverage that, you don't have to reinvent the wheel. So of course you could write a Prolog inside of Java that would have probably comparable speed, but then you'd spend a lot of time writing a special purpose Prolog.
Yeah, of course.
Yeah, like I'm not a Prolog dev, but like from my background, I was a data scientist. That I feel like I try to learn a little bit of Prolog. I feel like that's something that would be really helpful in dealing with data. So yeah.
Great. So apart from these, let's say, implementation.
Sorry, I seem to have lost contact here.
Oh, now you hear me well? No?
Yeah, I think I only see the comment that like maybe your mic is a little bit low, so that may be that's why we can't hear you very well.
Okay, but now do you hear me?
Yeah, I can hear, but it's a little bit low.
Yeah. So it changed at some point.
Is Gavin okay? It's like seems like he may lose the internet connection. Yeah.
Okay, this is quite bad, I guess.
Oh, he's gone. Yeah, that happened during our webinar before as well when I was interviewing him. I think we all have this internet challenge.
Yeah. I saw that webinar. I think you handled it very, very well.
Thank
Oh,
you. Because
is
yeah.
recording?
I'm
Hey, he's
back.
back. Hey, hey.
Sorry about that.
Okay. But it's fine. These things happen. And they especially happen during live webinars.
Yeah.
That's right.
It
It's
seems
twice as
it's
likely to
yeah.
happen.
They never happen during texts.
Yeah.
Anyway, apart from, implementation choices, maybe do you want to give us some technical overview about how Terminus works?
Yeah. So I guess the most interesting thing about it, I guess, is that we use it's an append-only database, the way that it's designed, and it uses succinct data structures to store the information. So a succinct data structure is a data structure that approaches the information theoretic minimum amount of space that is required to store some information. And we also have it's structured as a sort of self-index. So we store triples, and the information is stored as each edge is represented as a triple, a node, and then an edge label, and then a target. And that allows us to store an arbitrary graph. And then for some of the targets, we have data. So you can have data or a node as the target, and those are sort of segregated into two different cases. Each of these things is called a layer. So you store information about all of the added edges with their sources and targets, and then all of the deleted sources, targets, and their labels. So so each layer is comprised of these two sort of components. And then whenever you make an update or a change to the database, you stick another layer on top. And that layer tells you about which new edges you've added and which ones you've deleted. So when a query takes place, the query comes in, it hits a layer, and it checks to see if there's the edge that you're interested in there. And if not, it goes down to the next layer and down through all of the layers in the system. So that it's essentially a delta encoding strategy. And the delta encoding strategy is similar to the way that Git, for instance, stores information. So it stores in Git, you store all of the added lines and all of the deleted lines from the file. Because it's in this succinct data structure, it's relatively small amounts of information. But eventually you do end up with a lot of layers in the stack as you make transactions. So what you do then is you collapse the layers into a single roll-up delta, which just encodes some number of deltas as a single layer, and then you can use that as a diversion so that you don't have to go through the entire stack. So it's somewhat like a skip list in a way, because you can go to this other layer instead. The structure of that, though, it means that we can do all of the Git-like operations. You can do time travel. You can go backwards in time, see every different commit along the way. You can also do branching very simply, because you just point in at one of the layers and you can start making your own layers on top, and they point back through a different chain. You can do rebasing by taking some number of layers and reapplying them on top of another chain. And so these Git operations become very natural in this setting. So it seemed like a very easy way to incorporate these sorts of continuous integration, continuous deployment techniques that are used for software development in the database technology world. And then so in terms of performance, you lose in terms of you're going to create layers all the time, since it's an append-only data structure, and eventually that does mean that you are going to have to make decisions about when to truncate your history, so that you throw away history eventually if you're in a scenario in which you're doing a large number of large transactions. If you're doing something like the Seshat data bank, though, where the data is very complex, but it's not very large, you can store this information essentially indefinitely. So and it doesn't become a problem in terms of the quantity of data. So the compression is actually quite substantial. You can store a lot of information this way without ending up being very huge. So just to give an idea, we took a specific commercial intelligence data bank for one of our customers that was stored in Microsoft SQL Server, and it was about we loaded it in. The original database was essentially billions of edges, and we were able to get it in at somewhere around 10 gigabytes of information after it was put into a layer. So that gives you some idea of like how much information you could store in one of these. And of course, that 10 gigabytes is nothing in terms of the amount of RAM that you have in your machine. And if you get a big machine, a beefy machine, that's quite a substantial, amount of edges to have in a small amount of space.
Okay, that's great.
Yeah.
Check, do you want to add something?
Well, I don't know that much. I would only say that because I care about the clients and the front end side of things. I think what I really like about TerminusDB is that is flexibility. Like the schema is super flexible, and also we have all these API that we do have a very mature very mature client in JavaScript and Python, but also if you are using something else that you want to write your own API is perfect, because we just take in your query as a JSON LD, so that's fully flexible and it's open source, so that's great. Yeah,
exactly. Yeah, so I mean, we do get a lot of flexibility from that interchange format. It should be very easy for people to write their own libraries on top of us.
Okay, that's great. So I am curious about a couple of things. Given how Terminus write data, in case of a crash, is it always able to use the latest valid data?
Yeah, so okay, so if there is a crash, if the transaction has completed, then you will get a complete transactional picture of what has transpired. If the transaction hasn't completed, then you're guaranteed to have the last state of the database. Now, actually, that's not too hard to do in the event of append-only data structure, because we don't actually advance the head of the database itself until after everything has been written. So it's quite an easy operation. So once everything is written, then you go in and advance the head, and that advance the head is just one simple atomic operation. And so then you're immediately where you want to be. So the cleanup operation as well, because it is a sort of functional data structure, append only, we don't do any updates in place. You can have the delta rollups created completely in parallel. It doesn't have to, it doesn't have to know anything about the state of queries, what's going on. There's no locks. Nothing has to happen. All you do is you say, look, I want to make an equivalence with this layer here, and I want everything before it or everything up to some other layer, and I want to create one single delta, and that whole operation just happens completely in parallel, at which point you can atomically add an equivalence link after you've done that operation, and then it all works in place. So that's one of the advantages of this sort of functional data structure approach. I mean, there's disadvantages in terms of space, right? It would be more space efficient to write in place, but then you lose information at the same time. That's destructive updates lose information. So we gain something back there as well.
Okay, that's great. And can I also assume that because of this, one can even take just hot backups while Terminus is running?
That's right, exactly. So there's no problem with taking a hot backup. You can just say, okay, everything from this layer back, you just pull it out, and it works perfectly, as though nothing else is happening. So
that's wonderful. Do you have some kind of high availability solution also?
Well, we're currently working on getting Terminus Hub out, and that's we'll be rolling out features on Terminus Hub over time. And so that's, at the present moment, though, we don't have a complete solution to high availability, but we're intending to roll those out over the next 6 months or so.
Great.
Yeah.
What kind of solution are you thinking about to achieve it?
Well, the initial release of Terminus Hub is going to be, it's going to be like GitHub. So most of the operations that you do will be happening on your own database. So if you will actually pull from the remote and then update some transactional database that you have either locally or on one of your servers or something along those lines. So the server end will be high availability for that aspect of it. So you'll be able to get the layers that you want. You can do collaboration, and we will take care of all to make sure that that's a high availability solution. Now, the way that we do that is going to be the way that we're going to try to make it available to customers to use dynamically as a transactional database. And essentially, what we're using right now is we have a shared block structure for all of the different layers. And what happens is you have multiple different servers, and all of the servers can communicate to that block layer. They load those blocks into memory for the blocks that they're concerned with. And that enables us to have sort of a large shared memory store of the written information, and we write down the transaction logs to these layers are also written to this shared storage, but you have an in-memory version of only the layers that you're interested in, or the layers so you can segregate users amongst the different servers, and they'll end up with different layers present in memory, but they all use this shared block storage.
That's fascinating.
Yeah. So it scales very well, right, Gavin?
Yeah. So it scales up quite well. So I mean, there's some trade-offs, right? There's some downsides in terms of trying to get that shared network available block storage system that has some kind of latency issues and stuff like that happen. But since most of the queries and operations will happen in memory, that doesn't slow down the in-memory operations at all. And so you can just have a snapshot of the data bank. Yeah. Okay,
interesting. Okay, next question is probably mainly for Cheuk, finally.
Okay.
But of course, Gavin can also answer. So basically, I've noticed that you made a lot of efforts to build a community around Terminus. And well, of course, I don't have a lot of visibility on which results you achieve, but from the outside, I would think that it's going very well, right? So first of all, I wanted to ask, I mean, how did you achieve to build a community in a very, very short lapse of time? Because, you know, for some projects, building a community took probably years.
Yeah.
And you probably managed in months.
I think the thing, first of all, like, because TerminusDB is a very good product, I would say, that we attract a lot of interest in it. So every time, now I can't go to conference, but before I went to conferences, I would met people that they seems very interested in it, and they would, you know, because now the world need the graph database, so there's a need of it as well. So that's a perfect match, right? You have something that is really good and something that, you know, people want. So that's already like a good start. But I think the rest will be like how to bring people in, so we kind of connect people who are interested together. So also we have now well, before we have a Slack channel that people could you know, ask questions, but I think it just get better when we we moved to Discord because we have more interaction there, because Discord was built for gamers, and I think that's they like those companies who do games, they know how to get people hooked. So I think they also provide a lot of emojis, a lot of gifts for people to make fun of, like have fun, and and also I think the team did a really good job of answering questions. Sometimes, like when I check, it's like the questions already answered. I was like, oh, I'm too slow. I want to answer that question. So I think like having that Discord server for the community is very important. But also at the same time, we work very hard on providing content that we like even though like sometimes it's something that not directly related to TerminusDB, we have our meetings every week that we want to share knowledge. We would just now we decided to have some of them uploaded, so we share with the people in the world. And also like I'm trying to making tutorials for people, like even we have members in we call them 5-star terminators, so they are the very active members in the channel that they can give a mini webinar, they can build a tutorial, and we would totally appreciate that. And would I even put that in I'm working on the documentation for the new the hub, and then I would put the if you have a very good tutorial, let me know. I would put your tutorial in our documentation, so just to you would be popular in the community, and also you would become a 5-star terminator. So yeah, I think it's going well, and I think it's a work of not just me but everybody together.
Yeah, I think that's a great answer. I mean, it has a lot to do with Chuck putting the yards in. So she's really done a great job on it, and I think that's part of why. But I mean, we're also a fully open source technology, and we're really we want to grow. To be a proper open source technology, you have to have a community that's willing to engage with it, to help with it. And we've had lots of engagement even at the database core level on both the Terminus store and working on the succinct data structures, but also working on the Prolog server. So we've had work also on some of the clients as well. So we've gotten lots of activity in the community, and we're really happy about that. And it has been quicker than like when we were first open sourcing it. A lot of people were saying, "Oh, well, don't do that because it'll take ages for you to build a community, and then it's not really worth very much in the end anyhow." But we found it to be completely the opposite. It's gone quite quickly, and people, I think Chuck is right that there's a niche there for graph databases, for a really open source graph database product that people can get involved with. And I think that's part of it, that the features are good and the quality of the software is good, and so hopefully that'll sustain itself.
Okay, let me say that I love the term terminators.
Yeah.
In terms of code contributions, how this community activity is important for you currently?
So in terms of code contributions, I can just say in Terminus store, there have been some very, very significant contributions already. So like, thousands of lines and really quite serious ones as well. In Terminus server, in the Prolog, there have been fewer contributions. So maybe it's the difference between Prolog and Rust. And the Rust community has been more helpful so far, but there have been some useful, definitely, that we folded in dozens of patches from people for the Prolog as well. So I know less about the front end stuff. That maybe Chuck can answer for that.
Yeah, I think right now we do actually. I'm quite surprised that we actually do have contributions occasionally, because right now I think the front end is less of a it's not as big. It's just a very niche, tiny little clients that it could make you use TerminusDB much better. But we do have contribution, even like for the Python client, we do have contributions for the documentation. I really appreciate that, because like docs are very, it's not the most exciting bit, but it's the very important bit of the open source, tool. So I think, I'm really surprised by we do have people dedicated to work on our work. So yeah.
Yeah. I totally agree that documentation is very, very important because a feature does not exist if you don't know that it exists.
That's
And
right.
and it's better not to exist if you don't know how to use it properly. So documentation is definitely important.
Yeah.
That's it.
Do you also see activity in, things like building third parties tools or secondary projects?
I think that would be great. That's why
But
we have this API open, right? Because like
okay,
people can build their own third-party API if
okay.
they want to, yeah.
But is it happening already or
Not
not?
really, not yet. Well, not that we know of. There
Okay.
may be things out there. So the front end APIs are written with an Apache license, so people can actually go off and make their own derivatives and use them in commercial products, and they wouldn't even necessarily have to tell us that they were doing so. But right, so
Not of course. But I say this to people who's listening the interview. If you have an idea, build
Yeah.
a tool for TerminusDB.
definitely,
Yes,
definitely.
I can. Let me know. You'll be 5-star Terminators, and we would, you would definitely be appreciated. I can assure that. Yeah.
Okay, that's absolutely great. Let's think about the community chapter. For other projects, I mean, maybe not competitors, but there are a lot of software projects that may somehow interact with TerminusDB or maybe not. So for them, do you have some advice or some good practices to suggest to build a proper community? Or the opposite, do you have maybe some bad practices to suggest?
Well, well, yeah, that's a very difficult question actually. I think right now we also, because we're young, we learn from the big giants. Some
Yeah.
other, we learn from lots of different tech communities. For example, Mongo, they have a really good and big and dedicated community. So we're just trying to learn like how they can, have so much support from the community, and so we learn from others' experience. Also, myself, I go to I will talk with other DevRels in other companies. I will go to conferences to, to learn from their experience and to try to see what's best. Because sometimes it works. It also depends on the product. You may have a slightly different community, so sometimes you have to feel and try what works for you, what doesn't. So yeah.
Yeah. But it would be interesting to talk again, maybe in 1 year or 2 years, and then you can tell me what it worked in the
Yeah.
meanwhile for you. I mean,
Yeah, I think
oh,
at that time we would know. We have done the experiment.
but we will talk even sooner than that, of course.
Great.
Okay, so of course I'm impressed by all the explanations about Terminus, its internals, how it writes, and so on. And I hope that other people watching the interviews are also impressed. So my question is, if someone never heard about Terminus before and maybe wants to learn it or at least try it, where do you suggest to start from?
I would suggest to go to the bike tutorial because we do have some resources for beginners. We do actually I think we are putting everything together now to have a new documentation. So we'll have a session just for people to get started. So it will include our quick start guide, which now is available as a blog and also in GitHub. So the quick start, if I know that most dev will already have Docker, so that's very easy for them to get started. And we have a bike tutorial, which is designed for people who just installed TerminusDB and want to try out. And also the community, go to join the community. If you encounter any questions or hiccups, go there. Everybody would there to embrace you and help you. So
Okay, great. Feel free to post maybe a link in the chat so people can just
Yeah,
follow
I
the
think I
links.
just
And
post the link for the Discord server. So if
great.
if any viewers hasn't joined yet, so I would recommend you join there. Even just if you don't have questions, you can just hang out there and read what other people's doing. Because sometimes people would say that, oh, I'm working on this project, and it's very interesting. I'm always amazed by what people do in the in the Discord server. So yeah, it's a good place to hang out.
Yeah, exactly. And we're right now, we've just been working like mad to get out Terminus Hub, our hub offering. And once that comes out, I think it'll also ease the pathway for people, because you'll be able to get data sets that are already pre-curated. You'll download them and we'll show you how to do some queries on the back of them and alter them or something like that. And that way you can have a much more sophisticated database already constructed and easy to get.
Okay. A question is about use cases, real world use cases. So is there maybe a most interesting use case that's already in place, someone that is already using Terminus in a very interesting way, and maybe you want us to know about?
Yeah, I mean, I guess we have a few use cases that are already in place. One of them is the global SESHAC Global Historical Databank. I think that's really up there on the list of interesting use cases for databases across the board, because they're doing predictive analytics on history and actually looking at what causes crises, what causes collapses of states, what causes like conditions of which is sort of relevant to the present age of COVID and the difficulties that different states and the different ways that they've dealt with crises. So this is I think it's a very relevant subject to the present, and so that's one of my favorite examples. But there's also, we are using it for supply chain optimization, and so that's an industrial application, and graph databases and knowledge bases make a good way of dealing with those, because you have some sort of natural sort of topological structure. You have a lot of different disparate data from different areas that you need to get together, and then the sort of get for data like features are useful because you want to do machine learning off the back of this information that you're getting in from lots of different sources, and machine learning generates its own data, and that data is also complicated and needs to be stored somewhere, and also potentially needs to be stored in such a way that you can do experiments where you don't actually put it into production directly, but put it into some sort of branch type of object that you can test it on, and then you could move to master later. So that's those are some of the use cases that we're currently working on.
Okay, great. I have a last optional question, which is not really related to TerminusDB, but given the time we're living, maybe it can be interesting, because, well, I think that you are a distributed team, and probably you see regularly multiple customers. So I wonder if you have some suggestions for the companies that, maybe they're not used to work remotely. Maybe before COVID, they were used to work in a single office and have physical relationships, and now they can't, and it wasn't their choice, and the change happened quite all of a sudden. Maybe you have some do's or don'ts to suggest for these people.
I think right now that we actually like again, Discord is really our our favorite tool right now, because we started, when this started, we moved the work workspace, from Slack to Discord, and I think it really helps because we can have a voice chat there. We could sometimes we move our meeting there because it's more convenient, and we can do pair programming there. And I think what's also good is that our colleagues organize a team lunch every Wednesday. So even though you may be working at home, you may be doing something else, but you just for that lunchtime that we gather, we talk about something that's not work related. So there's still some human interaction there to keep the spirit up. So yeah, and we send like funny gifs and have a channel for funny stuff. I think just keep the spirit to still be happy.
That's right. Yeah. I think those sort of water cooler type spaces are really important for people to just have random chats and then chat about random things, and then we find out that sometimes it ends up being work relevant, sometimes it's not, but it helps to build a sense of community in the company. I think that's really important.
And can make nerd jokes.
Exactly. And Discord is fantastic. Actually, we were on Slack before, and we'd spent a lot of time together in offices together. So we did actually, even though we're a distributed team, we came together quite a lot and worked together physically. So it was still an adjustment for us to go to a completely distributed team. So now we're 100% distributed. We never see each other in person, but because of the lockdown. But Discord has worked wonderfully for it. And like Chuck said, we do pair programming on that. It's not just an occasional thing. We're doing pair programming all the time on Discord.
Okay. Yeah, interesting. Well, thank you a lot. And I have just a final question, which is for you both. I mean, I expect two different answers. And the question is if you can suggest 2 books for our viewers. One book, which is, if possible, database related, and another book, which is on any other topic you like. Because, people have a lot of time to read now, so.
Wow, I'm so busy. I'm busier than before. So yeah, I do have books I want to read, but never touch them.
Oh.
But my personal, I have a book. I wish I have it handy here because, like I said, I put it away. It's a book that I really like. If I can find a name, maybe I can send you after. It's maybe not very useful for the viewers because it's for me because I graduated with a physics degree, not in computer science. So that's the book that recap all the things that got taught in university, computer science, curriculum that, is condensed into a book like this thick, only like this.
Fantastic.
So I think it's a very handy book that, some concepts, that you may put it away because you've been working for 10 years, that it's good to go back to it. And but for me, because I didn't study university for computer science anyway, so it's good to sometimes the terminology to be precise about what I'm talking about. That's very handy for me because I work with developers. I want to make sure that I understand them and we can communicate. So yeah.
Great.
Yeah. So I guess for myself, the 2 books I guess I would recommend are Transactional Information Systems, 3 Algorithms, and the Practice of Concurrency Control and Recovery. That's Morgan Kaufman's series in data management systems. And that was a very influential book on me. I found it pretty impressive. And there's still a lot of ideas in there that I would like to be able to put into Terminus eventually. There's stuff about commutation of write commits that always struck me as really beautiful. And I've never seen it actually done in a database system, but I would like to employ it eventually. And I think Prolog serves as a relatively natural place to try to experiment with that because it's you can do very high level manipulation, symbolic manipulation of the query information. So, and the other one I really loved was The Art of Prolog, which is a great book. And I think it's a deep book in a lot of ways for people who are just generically interested in computer science, because you can look at meta interpretation in there, and the meta interpreters that he writes are just unbelievably cool. So in terms of abstract manipulation, I think it's very good. And databases seem to me a place where there is a possibility for a lot of these techniques of some symbolic manipulation to really improve performance and reliability. And I think that we've only sort of scratched the surface. There's a lot of space there to move forward with.
Definitely. Okay, so, well, really a classic. I mean, the book about transactions is really a classic.
Yeah, it's like a must-read for database.
Yes, and I agree that whoever has not read it, they should. Okay, so it was really interesting for me. Thank you for the time you dedicated to the interview. Really an interesting time for me, and I hope that the viewers agree. And 2 weeks of databases will continue tomorrow with another great interview to the DexterityDB team. If you don't know what DexterityDB is, it is a good reason to watch the interview tomorrow. And so thank you again, Cheuk and Gavin. I hope to meet you again very soon, virtually or hopefully even not virtually.
Yeah,
exactly. Thank you, Federico. Thank you.
Bye-bye.
Thank you very much and stay brilliant.
Bye.